Back to my YouTube channel, Sriram Devarajan. Today I am going to discuss another set of problem from KSET 2024 Mathematical Science question paper. This is my part 4. Already I have uploaded part 1, part 2 and part 3. It is available in my YouTube channel. You may check in the playlist KSET 2024. This is part 4 of KSET 2024. I am discussing the first problem. The continuous image of a connected metric space is option 1 connected, option 2 not connected, option 3 compact, option 4 not compact. We have to check whether the continuous image of a connected metric space is option A connected, 2 not connected, 3 compact, not compact. By well-known result, continuous image of a connected metric space is connected. Therefore, for the first problem, option 1 is the correct one. Now I am going to discuss the second problem. The second problem is let u of x comma y be the solution of uxx plus uyy which is equivalent to 64 in the unit disk set of all x comma y which is equivalent to x square plus y square which is less than 1 and such that u vanishes on the boundary of the disk then u of 1 by 4 comma 1 by root 2 is option 1 7 option 2 -7, option 3 16, option 4 -16. In the second problem, it is given ux comma y be the solution of uxx plus uyy equal to 64 in the unit disk x comma y, which is equivalent to x square plus y square less than 1. And also one important information is given, u vanishes on the boundary of the disk. Unit disk is x square plus y square less than 1. Boundary means x square plus y square equal to 1. On the boundary, u vanishes. U vanishes means u equal to 0. These two very important for solving this problem. And we have to find what is the value for u 1 by 4 comma 1 by root 2. Whether it is 7, -7, 16 or -16. Solution. What is given? uxx plus uyy, which is equivalent to 64. I am going to construct one function u that is equivalent to k into x square plus y square minus 1. Whether this condition holds for this u, x square plus y square equal to 1. If you substitute x square plus y square equal to 1, what will happen to u? U is 0. It satisfies the condition. Therefore, u must be taken as k into x square plus y square minus 1. Now, find out ux. 2kx. uxx, which is equivalent to 2k. Then find uy. 2ky. What is uyy? 2k. Substitute both this value in star. What is star? Star implies 2k plus 2k, which is equivalent to 64. 4k, which is equivalent to 64. What is k? K is 16. Substitute k equal to 16 in 1. Therefore, u equal to 16 into x square plus y square minus 1. Now find the value for u 1 by 4 comma 1 by root 2. That is, x is 1 by 4, y is 1 by root 2. 16, 1 by 16 plus 1 by 2 minus 1. 16, LCM is 16, 1 plus 8 minus 1. 16 cancel. Sorry, here 16. 9 minus 16, answer is minus 7. For this problem, second option is the correct option. Let f of z, which is equivalent to z power 4 e power z square for z belongs to C, and let gamma of t equal to e power it 0 less than or equal to t less than or equal to 4 pi. Then 1 by 2 pi I integral over gamma f dash of z by f of z dz, which is equivalent to whether first option 2, second option 4, third option 8, fourth option 6. See, in this problem, straight away after seeing this one, it is easy to identify the problem is based on argument principle. Solution. What is argument principle? 1 by 2 pi I integral over gamma f dash of z by f of z dz is n minus p. Equation 1. This is argument principle theorem. For this problem, first of all, find here and also one must note that n is number of zeros, p is number of poles. Here, what is f of z? Z power 4 e power z square. Here p is 0 since there is no pole. Also, there is no denominator term. There is no pole, there is no denominator term. Only we have to find number of zeros. We have to find, for finding number of 0, equate the numerator to 0, that is z power 4 e power z square, which is nothing but f of z, which is equivalent to 0, which implies z power 4 equal to 0 and e power z square equal to 0. Z power 4 equal to 0 implies z equal to 0 with counting multiplicity 4. But e power z square equal to 0 as no zeros, since it has no solution for any finite values of z. Therefore, n is equivalent to 4. Also given in this problem, 0 less than or equal to t less than or equal to 4 pi. This means that there will be 2 rotation. One rotation means 0 less than or equal to t less than or equal to 2 pi, but it is given in the form of less than or equal to 4 pi. Therefore, there will be 2 rotation. 2 rotation is nothing but one rotation is like this, 0 to 2 pi. Again another rotation means 0 to 2 pi. Again second rotation 2 pi to 4 pi. Therefore, our problems becomes LHS, which is equivalent to not n minus p, it is 2 times n minus p. 2 into what is n? 4. poles 0, 4 minus 0. 2 into 4 is 8. This is nothing but 1 by 2 pi I integral over C or integral over gamma f dash of z by f of z dz. Answer is 8. Third option is the correct option. Problem number 4. The complete solution of the differential equation x plus 2 whole square y double dash minus x plus 2 y dash plus y equal to 0 is a into x plus 2 plus b x plus 2 a into x plus 2 plus b into x plus 2 log x plus 2. Third one, a sin x plus b cos x log x plus 2. Fourth one, a into x plus 2 plus b x plus 2 log modulus of x plus 2. For this problem, we have to find the complete solution, which is of the form x plus 2 whole square y double dash minus x plus 2 into y dash plus y equal to 0. Among the four options, which one is the correct option for this second order differential equation? Given differential equation is Legendre differential equation. Given Legendre differential equation is x plus 2 y double dash minus x plus 2 y dash plus y equal to 0. Here, what is d by dx? That is caps D. Therefore, this equation becomes x plus 2 d square minus x plus 2 d plus y equal to 0. Further, I am going to take x plus 2 as some which is equal to e power z. Z equal to log modulus of x plus 2. Since log is defined for positive real number, find dz by dx. 1 by x plus 2 into 1. Differentiation of x is 1, 2 is 0. 1 by x plus 2. Now find dy by dx. It can be written as dy by dz, dz by dx. We know the value for dz by dx. It is equivalent to 1 by x plus 2 dy by dz. Cross multiplying x plus 2 dy by dx, which is equivalent to dy by dz. It can be further written as x plus 2 of dy is nothing but d1 of y. Here d is d by dx, d1 is d by dz. Operator d1 means differentiation with respect to z. Operation d means differentiation with respect to x. Now x plus 2 whole square d square is d1 minus 1. Therefore x plus 2 d square minus x plus 2 into d plus 1 of y equal to 0 will becomes d1 minus 1 minus d1 plus 1 of y, which is equivalent to 0. It is nothing but d1 square minus d1 plus 1 of y equivalent to 0. d1 square minus d1 plus 1 of y equivalent to 0. Now write the actual equation. M square minus 2m plus 1 equivalent to 0. M minus 1 whole square equal to 0. M equal to 1 comma 1. Therefore complementary function, which is equivalent to a plus bz into e power m1z. Here m1 is 1. 1 into z is z, which is equivalent to a into e power z plus bz e power z, which is equivalent to, what is e power z? That is x plus 2 plus b e power z is x plus 2. What is z? Log modulus of x plus 2. Therefore for this problem, option 4 is the correct option. I will upload more problems from KSET 2024. This is my part 4. Remaining problems I will upload it in the next video. Already I uploaded part 1, part 2 and part 3. It will be available in my playlist of my YouTube channel. Therefore subscribe my channel, share my channel and like my channel. Thank you.